Hello, and thank you for joining us. Today's webinar is SimPrep Auto Diluter for Coolants in 200.8. Our presenter today is Jacob Harrington, Technical Product Manager for Teledyne CETAC. We will be taking questions, so feel free to submit your questions throughout the presentation using the question feature, and we will address them at the end. Also, this webinar is being recorded and will be available for viewing within a couple of days. You will receive an email notification once it's available. Now I'm going to turn it over to our presenter, Jacob Harrington.
Thank you for that introduction, Shelley. Appreciate it. I want to thank everyone for attending today, taking the time. I hope that you find the information presented valuable to you. We're going to talk a bit about the SimPrep, which is a liquid handling system that we provide for offline preparation of samples, and how it's been applied to these two very different marketplaces for 200.8 and for coolant sample preparation. So before we dive into the actual application data, I want to talk a little bit about the SimPrep itself and kind of do an overview of the product. So on the right, the picture of one of the configurations for the SimPrep, and it's based on CETAC automation. So Teledyne CETAC has been making sample introduction systems for over 30 years, including nebulizers and auto samplers. And the ASX 560 that you see there is the latest in a long history of excellent automation and sample introduction equipment. That is combined with the Hamilton MicroStation NL600 that you see, the little box on the left with the two syringes. The MicroStation is always pitched as semi-automated sample preparation, and that you still have to have an operator there to direct everything. With the auto sampler combined, we provide a fully automated sample preparation solution. This system uses the same sample racks as your ICP auto samplers, so you can easily transfer prepared samples directly over for analysis. It's got a small mobile footprint, very user-friendly software, and a lot of functionality for different preparations. And it can handle aqueous solutions of many different varieties, including the list here, such as soils, mining, drinking waters, waste, coolants, and so forth. One of the big questions we always get with the SimPrep is that people want to see the software, make sure that it really is easy to use, user-friendly, it's not overcomplicated. So what we have here is a screenshot of kind of your main interface within this software. It's a very familiar kind of Excel-like layout. The sample preparation can be added. As you see, everything here is just done in microliter volumes, but you can also enter in information simply as a 1 to 10 or 10%, and the system will do the math for you. And it's really pretty easy to use. You specify where you want to pull up raw sample, where you want to have your sample diluted into, and how much you want for your final volume, your volume of sample, and any standard additions that you might have. There are functions that you can build into your methodology for introducing air gaps between your diluent and your sample, and between your sample and any standards. And of course, you have full wash cycle control, so that you can rinse with a lot of diluent and rinse solution, or you can completely skip the rinse entirely depending on your application. And there's also some sample homogenization features as well. One of the nice things about the software that makes it really flexible is that the same sample list, once created, your sequence can be easily adapted day to day. So if you have routine preparations that you do on a regular basis, you can create the sequence once, and then you simply load and run that sequence each day, and it's a matter of just a few clicks. Now, the nice thing is that if you normally prep 60 or 120 samples, but you find that your last batch of the day only has 23 samples, it's very easy to take that existing method and simply select only the samples that you want to run to actually be prepared, and all the rest of them you just skip. And it's very easy to adjust your sequence. You don't have to build a new one or save any new files to be able to adapt it for the needs of the day. As it prepares those samples, you do get live progress. So the line that's actually operating or being worked on will turn blue. And then once things are done, you get that little check mark that you see on the bottom right that indicates that it's been prepared. Right in the middle, you see there's kind of a green triangle and then a double arrow. One of the really nice things about the SimPrep software is that as it's preparing samples, you can actually make changes to the sample list. You can add new samples onto the bottom with sample information. And that express feature there with the double arrow means that even if you're in the middle of a preparation, you have a sample that comes in or you find out that something needs to be expedited, you can very quickly put in that sample and then click that to be a double arrow. And what the system will do is it will finish the dilution it's currently working on. It'll jump forward to that expressed line, finish that expedited dilution, and then resume where it was previously to finish the rest of the run. And it does all that, like I said, you can make all those changes mid-sequence. It's very, very, very easy to work with. So here we have a short video that shows some of the functionality of the system, so you can actually see it in operation. So here, right at the beginning, the very first thing that it does is it sends the probe to the rinse station, and it primes the line with fresh diluent. Now, that first step is programmable, as are almost all the steps in the run. Now it goes in, it takes up a sample aliquot, and what you see here, these samples are actually coolant samples. We chose them because we thought they'd be easy to see kind of a final volume in the sample tubes. And then they're dispensed together. Now, you can see the Hamilton unit there has two syringes. It has a 1 milliliter syringe and a 10 milliliter syringe. And the real advantage of that is that it gives you the ability to handle large volumes with the larger syringe while you still have the precision of the smaller syringe to handle your sample uptake. The rinse step completes, and the rinse step I mentioned, it's totally optional, and you can increase or decrease the amount of rinse used to meet your needs. And then we simply speed up the video. You can see as it goes through and produces one prep after another. One of the really nice things here is that, especially when you're working with large volume tubes like these 50 mil conical vials, it would be very easy for an operator to accidentally pull an aliquot from the same tube twice. And with the volumes in question, they wouldn't have any easy way to know. With an automated solution, that sort of a mistake doesn't happen. Because you can obviously you can see that it goes through the program as designed, and even if a mistake was made in the program, you can always review the software later to ensure that things were prepared properly. We talked a lot about dilution. It does have other options as well. So it does more than just dilution. The system can do dispensing, dosing, it can do serial dilutions, it can split samples, which is kind of seen on the bottom right here. You can actually prepare a sample more than one way. So here we show it preparing a sample as a 1 to 10 dilution for an ICP-MS, a 1 to 5 dilution for maybe an AA, and then a 1 to 100 with a spike, perhaps for an IC or something like that. It can prepare the same sample multiple ways, and it actually is designed to do that more efficiently than if they were on individual lines in that and how it handles it. Also, the software is designed that if it does know it's going to dilute the same sample multiple times, it will automatically do the math for you to ensure that it prepares the samples from least concentrated to most concentrated to prevent any carryover. It can also spike samples, and that's kind of on the bottom left here. You can pull up your sample and then go pull up a standard, and that'll all be introduced into the final tube. It does have the option to put air gaps between your sample and your diluent, as well as your sample and your standard. And those air gaps help provide better washout as they provide a physical barrier to prevent mixing of the solutions. So now we're going to start getting into some of the application specifics. EPA 200.8 is a highly regulated market, but it's also very, very common for drinking waters and wastewaters run on ICP-MS. And one of the biggest issues they can run into is that the salt that can be in these samples is known to cause damage to the cones, and argon chloride is a known interferent for arsenic. So the samples are typically diluted at 10x to reduce the salt load and also to minimize any interferences and matrix effects that can affect your data. However, laboratory contamination can be introduced during that manual dilution process. And it's especially problematic as with the ICP-MS, you're looking at generally very low detection limits. So any contamination that comes from the manual prep becomes a much bigger problem. These dilutions can be time consuming. They're error prone because they're so repetitive, especially with waters. It can be difficult to know what you've diluted and how, and they can be a source of repetitive stress injuries. Even with a really good analyst, everybody makes mistakes from time to time. You've got a long day and you're doing your dilutions. You meant to make a 50x dilution, for example, but you accidentally slipped on the math and you make a 20x. Well, that's going to throw off your data pretty significantly. And when you're doing it by hand, maybe you could return and look at your pipetter and see what you did, to double check if there was an error. But most of the time that pipetter will have been in who knows how many hands in between then, and it would be difficult to actually check and see what you've done. One of the really nice things about the SimPrep is even if you do make a mistake in your sequence or in your software, you can go back, open up the file, and see exactly what you did. So it provides a record of your work. One of the first things we did, obviously one of the first things that we do every day in the laboratory is create a calibration curve. So we wanted to prepare this both by hand via serial dilution, and also we prepared it on the SimPrep. And here you can see on the right is our calibration coefficients, and the SimPrep is the blue, the hand prep is the orange. Everything was diluted from a 100 ppb stock, and both the hand prep and the SimPrep do produce good calibration data. However, you can see the zinc line there in the orange is actually a bit lower. It's about a 0.9978, something like that. And that's likely due to some contamination that came in with the hand preparation, specifically for zinc and possibly there on arsenic. And as you can see, we didn't have anything like that on the SimPrep, which produced slightly more reliable results. So once your calibration's run, you want to verify that it's actually good. So the ICV here is the second source. So after the calibration, we ran the ICV, and you can see everything comes in within plus or minus 5% on the ICV recoveries. And then we ran a CCV every 10 samples all the way through the end of the run. And you can see those tracking here. They're all easily within the EPA requirements of plus or minus 10% across all of the elements. And almost everything's within 5%, as you can see. In addition to that, we wanted to really show, take something that's known and trusted. So we did some NIST standard preparation. We prepared these at 5x dilution and ran those on our ICP-MS. And all the elements, we had a recovery between 92 and 102%. And these are, you can see the NIST standards, which we used there on the left. They're trace elements in natural water and water. Particularly of note, thallium, it's highlighted there on 1640A and silver in 1643F. They both had really excellent recoveries, and that's despite having known concentration that was actually lower than our lowest curve standard. So the SimPrep was able to prepare this 5x dilution very, very, very accurately and provide these excellent recoveries. In addition to those, we also wanted to do a standard with a slightly more difficult matrix. So we got this SRM from the National Research Council. That's from the North Atlantic Ocean. It's a seawater sample. This was digested according to EPA 200.8 requirements because it had higher dissolved solids, and it was diluted at 50x by the SimPrep. And there you can see the recoveries again are excellent. Recently had one of our local nature reserves, they actually had to put up this drinking water health advisory because they had high levels of manganese in their drinking water, their tap water, and their drinking fountains. And so they had to put up an advisory. Now, we found out about this because my wife had taken our kids there to go hiking, and she took a picture of it and told me about it. And I said, well, that's kind of exciting. We should get a sample. So we returned the following week with a big bottle because for doing application work, especially with waters, it can be really nice to have a solution that isn't just clean water. So we went back and got those samples that were high in manganese And we used them for a number of preparations for this EPA work. So the first thing that we did is we diluted the samples 10 times by hand, which is the far left blue, diluted them 10 times on the SimPrep, which is the green, and then the control was actually a single dilution in a large tube, but we analyzed it 10 times to provide essentially an instrument control that would rule out, be able to say what our instrument would do if there was no variability in the preparation itself. And what you can see is the RSDs across all three are very nearly identical. So excellent hand prep by our application chemist, very good reproducibility on the SimPrep as they both match the control. In addition to that, we also did some different types of dilutions with the sample, 10x, 20x, 50x, and 100x. We ran those in triplicate and then took the average RSD. And again, the idea was to try and get a sense of, we know it can do 10x really well, but what about if we do a wider variety of dilutions? Is our reproducibility still going to be good? And there again, the hand prep and the SimPrep are very nearly indistinguishable at 0.8% RSD. So very good RSDs there. We're able to get excellent reproducibility despite the different volumes being used. And the next thing we want to do is we actually did a preparation of lab control sample and then some matrix spikes on that sample of with the manganese contamination, excuse me. And the reason we show this screenshot is we wanted to highlight that the SimPrep is able to do the sample spike in a single step. So within the box, it does kind of a standard dilution of 1 to 10 dilution of the sample. For the matrix spike, or for the water sample, but then it also is able to add that 0.2 mil spike, and that all happens essentially within a single preparation step. And then those can be taken to be essentially put on the ICP-MS for analysis. So here we have our lab control sample, and then the sample itself, matrix spike and spike duplicate, looking at the sample recoveries percentages, and everything came back between 90 and 105%, which easily meets the EPA 200.8 criteria for all of those. So kind of encapsulate this. We know the EPA tightly regulates standards of performance. We also know that sample volume can be really high in some of these lines, is precious. So what the SimPrep can do is it can help you to satisfy the stringent requirements set by the EPA while improving your workflow and allowing your analyst to spend his time doing chemistry instead of just pipetting all day long. The SimPrep has been shown here to be equal to or better than hand preparation of samples. The automation provides consistent performance, and this can be really, really critical in a lot of the environmental laboratories. It is the calibration curve, QCs, matrix spikes, they're all prepared with very little analyst intervention, and any analyst can be trained to click a couple buttons on the computer and then provide reproducible and excellent sample preparations, which allows you to reduce reruns by having reliable performance every day of the week. Now we're going to switch gears and move over to Coolant Application. So coolants are in many ways very different. Coolants samples are typically 50% glycol or thereabouts, and they're analyzed on ICP optical instead of ICP MS. Now, we analyze the coolant samples. It's a growing part of the in-service marketplace, and these samples are taken frequently, and they're analyzed to look for trends. So essentially, for heavy machinery, the coolant samples will be taken on a regular basis and analyzed every few months. And then when they analyze it, they look back at the previous data for that particular piece of machinery to try and see if they're getting spikes on any particular metals or if any of the additives are starting to wear out. So the things they test for here: fluid contamination, did something else get into my coolants, excessive dilution, have we poured in too much water, for particulate contamination, and also, like I said, to assess the health of the additives. And the additives are elements that are added that really helps the coolant perform the way that it needs to, and those can wear out over time. This information is used to guide maintenance to improve the lifetime of the equipment and to reduce downtime. Essentially, what they want to use this information for is to do informed maintenance so that they know when something is starting to wear, when a component needs replaced, or when their coolant just needs flushed, and then they can do that at a time which is convenient rather than having a breakdown in the middle of a project. So for these samples, we're really lucky. We have a local laboratory called NMC that was willing to provide us with a variety of different coolant samples to be used. And you can see that's actually a picture of our samples there on the right. There were a lot of really interesting colors and different types there, and we're really lucky to have those. And so within those, a coolant of each type was randomly selected for analysis. Those samples were diluted 10x in triplicate by the SimPrep, and we dilute these samples because of the high level of glycol, that 50% glycol. You want to dilute that down to where it's just a 5%. That makes it a lot easier to introduce the sample for analysis. These were also spiked for various elements in duplicate, and one sample that we had a larger volume of was aliquoted 10x by the SimPrep to demonstrate the accuracy. So now we'll start to look at some of that data. Before we can analyze, obviously we need to calibrate. So the ICP was calibrated using a blank and 4 standards. These were prepared by the SimPrep in 5% glycol. And we're able to get excellent recoveries. The calibration curves here for copper and boron are shown. And then up above, you can see the actual screenshot from the SimPrep software. It's really pretty easy to do this type of work. You specify what tube you want to dilute in the position. In this case, we're doing 10 mils final volume, and then how much of the standard do you want to add? And the SimPrep can very easily make that happen. And even with the difficult glycol matrix, all the correlation coefficients for all elements were 0.999 or better. To verify that curve, verification standards were analyzed after calibration every 10 samples, similar to the EPA requirements, though this isn't necessarily normally done within the in-service marketplace. The initial calibration curve verification was prepared by hand from a second source. So that's different source, and it's prepared by hand to verify that everything was working properly. And the ICV there in blue, all the recoveries are within 10%. Most of them are easily within 5%. And then the CCVs were prepared by the SimPrep from the same source at half the concentration of the highest cal standard. So the figures can be seen here, and recoveries across the entire analysis were all within that 10%. We also wanted to do comparison, again, hand prep versus SimPrep on something that's a little more challenging with this because of the viscosity. So with that, the traditional pipetting techniques can be subject to error as the sample viscosity interferes with the ability of the user to consistently expel all the sample. It tends to kind of stick to the sides of the pipette tip, and different analysts can have different techniques affecting the accuracy. So what we actually did is we had 2 different analysts. We had analyst A in the orange, and she used the pipette every day, and analyst B, who used the pipette infrequently. They both took 10 different sample aliquots that they dispensed into cups, which were weighed. So this wasn't even analysis on an analyzer. This was purely by weight. And the SimPrep did the same way. The SimPrep aliquot, 10 aliquots into different tubes. Those were all weighed, and then we took the RSDs for those sets. What you can see is the SimPrep has the best RSD level for that, dispensing with less than 0.2% RSD, but the analysts did very well with 0.4% and 0.7% reproducibility. The real advantage of something like the SimPrep, I mean, in this case, it gave the most repeatable sample delivery. In some cases, you're probably going to have analysts that are better than the machine at preparing samples, but those analysts, they may take sick days, they may take leave, they may eventually get another job. And the nice thing about having an automated solution is that by incorporating that into a laboratory workflow, it allows for consistent sample preparation regardless of the operator. We also did sample spikes on this. That coolant samples and a 5% glycol blank were spiked with 0.5 mils, the second sort standard. You can see the final concentrations at the top right. Again, SimPrep's able to dilute the sample and spike in the same preparation step very easily. And we didn't include all elements in this spike simply because within the samples that we ran, a lot of the elements were high in certain coolant samples. So here's our recoveries for all these different elements. The laboratory control sample recoveries were all between 95 and 106%. And the sample recoveries, except for lead on C4, were all between 81 and 113%. So we're able to get really good recoveries here with the exception of that lead, and that's likely due to matrix effect and not an inaccuracy on the system, as all of the rest of the elements for the C4 samples there came in within a very good recovery. Lastly, we did a little bit of work to show the reproducibility. So the RPD was calculated for that lab control sample and for the spike samples. The LCS RPDs, so it's on the kind of a clean sample, those were all less than 3%, while the sample RPDs were all less than 6%. So again, this easily meets the 10% RSD expectation, and many elements had RPDs of less than 0.5%. And lastly, each coolant sample was also prepared at a 10x dilution in triplicate, and then we ran those and took the RSDs across all elements, demonstrating the reliability. And here you can see the reproducibility across a number of elements for these 5 different randomly selected coolant samples, and everything's 3.5% or better, so very good reproducibility there. So to kind of encapsulate this, we want to simplify your sample preparation. We know that coolants analysis, it's a growing need in many labs. The sample matrix can be difficult to work with, and as labs are adopting this technique, taking it in and adding it to their portfolio, there can be some growing pains associated with that. One of the things that can be done to help with that, provide your lab workers with an automated solution for the sample preparation. So the SimPrep provides excellent reproducibility with all RSDs under 5%. Your CalCurve, LCS, matrix spike can all be prepared with very little analyst intervention. It's a compact system, which saves valuable lab space, and it doesn't take sick days, it doesn't take vacation. It's always ready to perform. So in closing, the SimPrep automated liquid handling station, it's accurate, it's reliable, it's clean, and it's simple. This system can really help a laboratory to improve their workflow by reproducibly and accurately creating the samples every day, and by reducing potential sources of sample contamination or potential opportunities for error. So I know that was a lot of information. We went through it really fast. The good news is that these applications, all the data we presented here has also been published on our website in application notes. So we have application notes for the SimPrep for a number of things. We do have the application note for the 200.8, the coolants that we presented here. Those are both published. We also have a technical note that talks about how you can use one auto sampler for your sample preparation and your sample introduction. And we'll also be releasing an application note for a USP 232 methodology very shortly, hopefully before the end of this week. Those can all be found on our website, www.teledyneCETAC.com. If you go to the Resource Center, and you can find them, there's an application notes area there. And within that, you can search by product, by marketplace, and get the information yourself to review. With that, I want to open it up for questions. So if you have any questions, if you haven't submitted already, please do that. Go on the question tab, send them over. I'd love to answer a few more pieces of information about this product. Okay, this is a really good question. That's how do you adjust for the higher viscosity, like with Coolant Samples. So the SimPrep, it has a lot of options for optimizing the method to work for your samples. And a couple of them that are really critical is you can adjust the sample, the flow rates. So you can actually adjust how quickly the syringes will aspirate out of a sample position. And you can specify that for the entire sample rack or all the way down to a single tube. Like you can specify, I know this standard, we want to take it up at a lower rate. So you can specify the aspiration speed. You can also specify your dispense rates by location within the software, which allows the user to compensate for the viscosity. That's another good one. So another user asked, or attendee asked, can I use my existing auto sampler for the SimPrep? And that's absolutely yes. We've designed several different packages for the SimPrep. So you can get a fully functional system that includes a brand new auto sampler with the diluter and the software. We also have what we call an upgrade package for users who already have an ASX 560. It also actually can be used with the ASX 280 and with the previous generation of auto samplers, our ASX 520 and 260. So I know I've been to labs where they have a 520 sitting on a shelf somewhere in a closet that's fully functional, but they don't have an ICP to put it on at the moment. If you're in that boat, you can pull that 520 back out of the closet and purchase the upgrade pack for the SimPrep and turn it into a fully functioning dilution system for your laboratory workflow improvement. And then another really good question is, what is the time per sample for preparation? And that varies a bit depending on what you want to do. So as I mentioned, the system is very flexible. It's got a lot of optimization options for the users. Those can affect your time per sample. Normally for 1 to 10 dilution with pretty good performance, you're expecting somewhere in the around 35 seconds a sample. That's what I would normally expect for like a waters preparation. If you need to slow down the aspiration speeds for example, coolants, then that may increase the time a little bit. The other things would be, if you have a lot of rinse, that can slow it down as well. On the other side, if you're looking at something where you say, I know my samples, I don't need to have a rinse step between each, we can skip that. We can run at the max speeds for aspiration and dispensing. Then you can easily get it down to 20 to 25 seconds per sample. And for just the dispensing method with no rinsing at all, I think it's like to dispense 10 mils, something like 12 seconds a sample. So dispensing it does very, very quickly. It just goes tube to tube. So it really depends on what you're trying to do with the system. All right, I think we'll do one more here. The question of, can the system handle HF? This is a question we get from time to time. Currently, we don't have a supported option. We're looking into some options for running with HF, but the main SimPrep system still uses borosilicate syringes. So if you only need to introduce a small amount of hydrofluoric acid, you could put it on the auto sampler deck and then have it aliquot out of that into sample tubes, or use it like a standard spike. But we don't have kind of a full ability to run with HF at this point. Hopefully within the near future, we'll have a solution for that. All right. With that, I want to thank everyone again for attending, for your attention. I hope you found this valuable. If you do have any more questions, please feel free to contact me directly, reach out to your marketing person, or contact our service group at cetacservice@teledyne.com, or of course go on our website. You can submit questions there as well. And again, thank you all for coming, and I hope you all have a wonderful rest of the week. Bye.